Hi, Craig here. Today I want to talk about the 4 generations of high pressure common rail injectors. And I've got a couple pictures here that I'm going to bring closer so that you can see. This is the CRS1 here, and I'm going to bring this up really close so we can have a discussion about it and just get it right there. So this is the first of the 4 generations of the high pressure common rail injectors, and I'm going to explain briefly how they work. They use the principle of electromagnetic servo hydraulics, and what that means, and you can't see it in this picture, is you have a solenoid here, and it's connected to this rod. This is a little ball that we're looking at right here, and this is high pressure fuel. So all this is high pressure fuel. It comes in, goes down here below. This is what we'll call the command piston, and it goes above. Now, the amount of pressure working on this area, and there's a spring involved, holds this injector down. With this pressure working on this surface area, it holds it down. Now, alternatively, there is pressure pushing up here. So how this injector works is we have a computer that is timing when the injection should take place, and it charges up a capacitor bank. And when the computer decides it's time, it sends a signal to the solenoid, which releases this small rod, and then this high pressure fuel is going to force that ball up, and this fuel is going to go back down to the drain circuit. Now, when that ball is forced up because of the high pressure, this command piston lifts and injection begins. I should also mention that this orifice where it's being covered by the ball, there's also an orifice here, and they have to be balanced. So there's a number on the injector that is put into a computer when the injector is changed, so that the balance between this orifice and that orifice is correct. Otherwise, if this was too big, you would have a slow end of injection. So being that they're balanced, this ball will be lifted up by this pressure. That pressure will go to the drain circuit. This command piston will lift up and it'll inject. Now, when the end of injection occurs, the signal will go from the computer through the capacitors and close the solenoid. It will release or take the electrical signal away, and this will come back down by spring pressure. There's a spring in here, and it's not shown. So that's the injection. You can get 3 of those per combustion cycle on the CRS1. Now that was just about 20,000 psi. The CRS2 is right here. I'll just get a good picture of that. So it uses a ball. It doesn't look like a ball, but it is a ball here. And you can see now that we have 2 springs, and we can see the solenoid. Same idea. What's changed here is they've balanced the springs. Again, we're going to have high pressure fuel in this area. Oh, let's see here. We got high pressure fuel in this area, and then below the command piston. And when this is in the up position right now, but when it's in the down position, it's at rest, and the springs are holding it down. When the solenoid excites, now keep in mind this is a electro-servo hydraulic solenoid, it's going to lift up, pressure is going to flow to the drain circuit, injection begins. This was around 23,000 psi, and it was capable of 4, where the previous injector was capable of 3. The drain orifice in here is actually really easy to see in my coloring, in my drawing. And again, it balances between this orifice and this orifice to make sure that it's correct. Now, the CRS2 was better balanced with the springs and had a lighter servo valve. So it was able to open and close quicker, gaining the extra injection. So these were the early common rail injectors, and we can see we've gotten away from the great big solenoid on the outside of the injector. The parts are much smaller. We're using high pressure fuel to open and close the injectors, and only a small solenoid to control it. So I hope you found this helpful on how injectors work, and I will make some injectors for the CRS3, which is the 3rd generation of injectors, which we call piezoelectric.